So onto our last plant, our plant number E here. This one is just kind of a funny little one on the end. It's just a stem with some seeds arranged around it. It's going to sort of just flap around and blow in the breeze a little bit. Okay, so let's just start as always with a new geometry node here. Let's turn off our plant D so we're not viewing that. Create a new geometry here. Call this one plant E. Color it green. Let's just dive inside. So I'm going to start with a curve for this one. I'm going to come into our right hand viewport here, spacebar 4. Tap enter to enable our handle mode here. I'm just going to put down a few points, something sort of like this. Doesn't have to be exact. In fact, you feel free to go and make your own shape. I'm just going to go for something a little bit like this and just a little bit smaller than 1 unit length. Tap enter and let's resample this just to give it some more subdivisions. So I think about 0.02 for our segment length. Let's make it subdivision curves and let's just enable a curve U attribute here. If you need to, you can just come back and just tweak those points a little bit, but something along those lines is fine. So next, let's grab our Noisify VOP that we made in our first lesson, and we're going to use this just to add some noise running through our stem. If we come back to all the way back to plant A, all the way back at the beginning of this set of assets, and you might remember we created noise P here. If we go inside, it was just using anti-alias noise, and we're using our curve U to multiply against our noise and add that to our position. So let's grab this one. Just going to Control C to copy it. And let's come back to our plant E and just paste this one after our resample here. Play through it. I think I'm going to come here and I'm going to update, or sorry, I'm going to increase our frequency a little bit more, maybe somewhere around 7.5, I think, 7.4. I'm going to just reset our offset, delete the keyframes there just by revert to default, or delete channels, I think it would have been. Yeah, delete channels. Set that back to 0. And I think I'm going to animate our y-axis this time. So I'm just going to set that to be attribute time. If we play through this, we've now got this sort of little motion rippling through this. I'm going to bring up our ramp a little bit. This is remapping our curve U. So at the start, there's going to be no noise applied, and there's going to be a lot more noise, or full amount of noise applied at the end. Also going to give that a bit of smoothing, just so I'll set that to be monotone cubic. And I might just bring up the amplitude a little bit more, maybe about 0.3. Cool. So we've got this nice little sort of movement running through our stem now. Okay, so next I'm going to add some normals to this. I'm just going to use our orient along spline, or orient along curve SOP. So here we go. We've now got normals running along our tangent length. I'm going to actually disable our up because I'm going to create this later. And I'll show you how we do that later on. I think for the next bit, we're going to carve this, and we're going to use this as a way to grow on our stem over our animation. So let's put down a carve. We've done this before. Just going to disable our first U, enable our second U, and we can animate this just to grow on our stem. So let's go to frame, say 100. I'm going to keyframe this at 1. Let's come all the way back to 1, and I'm going to set this to be about 0.05, I think. Let's alt click to keyframe that and shift click on it to actually open this up. And as always, I'm going to add a bit of ease out to this just so that it slows as we get to the end. We get this kind of feel to it now. Okay, at the moment we are changing our point count. In fact, if we see, as before, as we go through this, you can see our point count is changing per frame. And because of motion blur, I want to keep this consistent. So I'm just going to come back here, put down a resample. Like we did before, I'm just going to set this to be a fixed number of segments, probably about 90. Make it subdivision curves. And there we go. So this is going to be our stem. Let's create some geometry for this. And as always, I'm going to sweep this one. So let's just put down a sweep stop. Probably my most favorite node at the moment. I'm going to make the surface shape be round tube again. Let's bring down our radius, I think about a little bit smaller, about 0.015. And I'm going to give our end cap to be a grid, so we've got round edges there. So this is now what we have. Okay, so let's now create our seeds along this stem. So I'm going to carve out a section of our spline once again, probably from about here to about here. And we're going to fill this with points that we're then going to use, copied of points, to clone seeds onto. So let's go back up to our resample just above. I'm going to put down another carve. This time I'm going to go from about 0.25, I think, and I'm going to trim it all the way to about 0.95. So we're just taking this section here. This is going to be where our seeds are going to be placed. I'm going to resample this once again. So we're now just resampling the section that we have set up to be our seeds. I'm going to set this to be a maximum number of about 140. So we've got 140 points here. Let's treat that as subdivision curves. So we're going to have 140 seeds running down our stem here. Okay, so we have normals at the moment facing up along our curved tangent like this. Now I want our normals to actually be running perpendicular to this. And we can use what's called the cross product for this. Now the cross product is such a useful function in Houdini. Essentially, if you give it two directions as vectors, it will give you the perpendicular direction based on those two vectors. Might sound complex, maybe, but I have a few examples here just to demonstrate and show you how this works. So I'm just going to come up here and click on my examples, and I'll include this in the scene file so you can have a play around with this as well if you want to. So I'm going to dive inside this example setup box here. So we have two vectors here at the moment. These don't have to be anything in particular. Let's say this is our normal. Let's say this is our up vector, but really these could be any directions based on a vector. Now, if you were to imagine that we were to create a polygon triangle based on these two edges, connect it back to the start, kind of like this, then the cross product will give you the normal of this polygon face, which would look essentially like this one here. So even if we rotate our two normals and give it like a really, really narrow range, you can see we've still got our polygon there, and the normal of that is still facing in this direction. So even if we go like this and adjust this, we're still getting a consistent normal based on these two angles. And of course, if you rotate these around, you can see we get this really nice sort of hinging effect. So again, you just have two vectors, and the cross product will just return a direction that's facing along this line here. And just to show another example of what you can do with this, often it's quite useful for doing things like grooming normals on geometry that maybe you want to scatter things on with a copy to points, or maybe you want to create a custom velocity that you could use to drive a particle sim around your geometry. If you just take a grid like this and maybe add a mountain to it, we can add some normals to this and we could scatter some points onto this. So we just have points now with a normal attribute running like this. So if we were to call our cross product on our normal, and let's use just the normal y axis, so just straight up and down y axis as the other vector, you'll be creating a polygon based on those two edges, and you'll get a normal that will kind of rotate and move around the contours of our geometry. I'm just going to show you what I mean. If I put down a point wrangle here, let's make our normal be equal to the cross. This is the cross function. Just need a vector A and a vector B, and returns the cross product between the two vectors. So we're going to use our current normal for the first vector, and let's just set the second vector to be our y-axis. So 0 for x, 1 for y, 0 for z. Close curly brackets, close that out. You can see these now have flipped, and they are now running at the cross product direction of our original normal. So we get this nice sort of almost like a flow field effect. And again, if you use this on a particle sim, perhaps you would get like a nice motion that would flow around the contours of your geometry. So the cross product is useful for a lot of things. Well, it does one thing, but it can be used for so many setups. So it's a really useful function to know. Now, one more thing to know. At the moment, these normals aren't normalized. You can see we've got different lengths here. Some are longer than others. So it's also a good idea just to normalize our cross product as well. Now we have unit vectors of 1. And incidentally, if you did want to flip the direction to go in the other way, you can just put a minus before this, and it's going to negate the vector. So like that, now they're going in the other direction. So it's pretty cool, as we said. Let's go back now to our setup, and we can use this for real on our setup here. So we have our normals, as we said before. If I was to call the cross product of our normal based on, let's say let's do it along our x-axis. We can do the x-axis? No, I think we'll do it along our z, sorry. So we've got our normals, we've got our z-axis. If we do the cross product, we'll get our normals become the sort of perpendicular angle based along here. So let's put down a point wrangle. I'm just going to do exactly the same pretty much as I did before. First of all, I'm actually going to store this normal though, and I'm actually going to convert it to be just an up vector. So we're going to say v at up equals attribute normal. So we're just essentially copying this over, and this is now both our normal and our up. So let's now adjust our normal by saying attribute n equals cross. We're going to use our current normal, and we're going to take our z-axis. So if we put 0, 0, 1, close that out, you can see we're now running them down the side of our spline like this. So kind of like 90 degrees from where they were before. So let's also normalize this, because we want to make sure we're not getting different length vectors for this, to know they're all the unit length of 1. Cool, so we're going to use these points and these normals to align the seeds on our stem now. Let's put down a sphere. It's going to be some quite simple geometry here. It's not going to be too complicated. I'm just going to go for a simple polygon. Going to reduce our uniform scale way down to about 0.02. Zoom in here. I'm just going to increase the frequency to 3 just to give it a bit more geometry to work with, a bit more subdivision. I'm going to stretch it out slightly along our, let's not do it on our x-axis, we need this to be on our z-axis, because of course we're going to be using copy to points, so we want this to face the direction of our normal. So this is our positive z direction this way. Just bring this out, stretch it a little bit that way, just bring it forward so it's just sort of sitting just in front of our origin there. So use a copy to points. Connect that to our points there, and we've got this running up our spine. I'm going to also add an attribute randomize here to just randomize our p-scale a bit to give us some more variety there. I think I'm going to go for about 0.3 minimum, max value of 1. Just going to give us some more variation like that. Okay, so we've got these aligned to our normal so far. Now I want to rotate these around our spline in a spiral, and we can use our matrix functions that we used before once again here. So we have a normal where our geometry is pointing, and we also have our up vector, which is running along our curve. So if we were to rotate our normal by our up vector, we'll get rotation that kind of follows along our spline. I'm just going to show you this now. So let's put down, before I copy the points, let's put down another point angle. Let's call this rotate n. Hopefully you remember from before, we can just create a matrix. Call this M. I'm just going to create the identity matrix. Now we're going to rotate this matrix M by an angle. So it's going to be, let's use just a channel float slider. Call this amount. We're also going to convert this to radians because Houdini works in radians. So we convert that. And in terms of the angle we want to rotate around, let's just rotate it around our up vector. So V at up. To create our slider there. And then finally, let's just take our normal, so attribute n, we're going to do times equals our matrix. And of course, we also just want to come up here to our parameter interface and just set this to be a bigger number, maybe 180 for now. Apply and accept. So with that done, we can now rotate this. And if I come here, actually view our output of our wrangle here, you can see we can rotate these around our spline, which is a pretty cool function. So in order to create a spiral, I'm just going to now multiply this number by our point number. And remember, our point number would go from 0 at the base, 1, 2, 3, 4, 5, all the way to our number of points. So let's just say, take our angle here, let's multiply this by attribute pt num. So now we have this kind of cool way of generating this spiral around our geometry or around our curve. And then of course with our clones enabled, we can do this, which is already pretty cool. I'm going to set this value to be 137.5 to be specific. And some of you may know that this is kind of the golden angle used in plants and things like that, also known as like the Fibonacci spiral. And this is also kind of the sort of arrangement you would get in things like sunflower seeds and things. It's sort of like the nature's very beautiful kind of arrangement of things. So if we use 137.5, we get this really nice arrangement like this where everything seems to be rotated in a very sort of organic and very nice way. So let's have a look at this now. Press play. We've got this kind of interesting setup here. Pretty cool. I'm going to also, as well as this, I'm going to actually add our time to this. So let's say this is our angle, let's say plus attribute time, let's just say times 3, for example. So we're going to add a little bit of a value each frame. This is going to allow us to rotate. So now we're basically randomizing and rotating our seeds around this. Let's just come back up to this. Let's take our sweep, combine this with our copy to points. And I think I might just bring down, let's go to our curve 2 here where we actually set sort of like the range of our seeds. I might just bring this one down a bit lower, around here, about 1.8. And I think I'm going to go to our attribute randomize. I'm just going to bring up our max value here to maybe about 1.3. So now we have this kind of thing going on, which I think looks pretty cool. So in our next video, we're going to sort of finish this one off. We're going to finish off our animation and we're going to sort of put in a few parameters to allow our setup to scale as it grows.